This is a topic that has been very important to me for decades, but I really got active maybe about 10 to 15 years ago. It was just getting out of hand. And in my role as a broadcast engineer, all these years, I do hear from listeners with their problems of reception. And indeed, the radio noise problem is definitely growing and has been and continues to do so. So I think you guys are likely to be, as AWA members, as electronics and radio hobbyists, be familiar with the noise problem that I'm talking about. But not too many people who are outside of these circles would be familiar with it. The best way I can describe it to the general public has been using the term noise pollution. But hams and shortwave listeners and people who like to listen to distant AM stations are probably, I'd be preaching to the choir to talk to them. But I've talked to a lot of engineers who have no concept of this being a problem, both manufacturing engineers, and that's a big problem, and broadcast and other communications engineers. So I'm kind of being trying to spread the word, proselytize a little bit on this subject. So we do receive complaints at Wisconsin Public Radio, where I was for many years as director of engineering. We had very close contact with many listeners. We had a whole department for interacting with the listeners and the TV viewers and for the public television. But I could actually track some of the complaint and get some numbers on it. And over the 5-year period of 2010 to 2015, we'd had a 40% increase in complaints related to reception. And we had done nothing but improve our signals. None had gone away. None were at lower power. None had a compromised antenna, and many were better than ever. So the message was for these people, they were all longtime listeners, but the message, they were pretty much, you could summarize it as, they would say they used to get good reception, but not anymore. So they're using the same radios, the same antennas, but they're not hearing our stations as well. And this is mostly FMs in this example, but we had 2 AMs and what at that point probably 30 FMs and 2 AMs in our network. And when I would consult with these listeners, and I have also done so as when I worked with iHeart and now with WWVH, I have seen this very strong pattern that nothing has changed with the transmitted signals, nothing much has changed with the receivers and their antennas, but the difference is over time, the noise level around the receiving system has increased. And that is the problem in a nutshell. The overlap of the desired signal by an interfering signal, whatever it might be, tends to be the main cause of these complaints. I do feel that public interest and awareness of this is pretty low. I think people, if they do have any sense of this, they just think it's something that bothers AM radio. And while AM certainly is a victim, FM, TV, shortwave, all the two-way radio communications, RFID, I've heard problems with people, stores that have, and warehouses that have RFID problems. Wi-Fi, Bluetooth. There was a great one with car remotes that didn't work in about a 1 mile square area in a city. Wireless security stuff has trouble. So in all these situations, there's an expectation of good signals and getting whatever desired result is going to come from these products and these systems, but it doesn't pan out always, and it's often because of the noise. AM is just probably the one mode that is most easily, you can most easily hear the noise. And so it sort of hits you right in the face. But on FM, for example, the limiters in the receivers will cut out a lot of the amplitude-oriented noise, but there can still be interference. The capture effect of the radio also helps you avoid hearing anything but the desired strong signal. But this rising noise floor does tend to make people perceive the station as being weak. That's the usual way it was described, but it was just that the same old signal that we've been sending for 30, 40, 50 years had gotten lost in a sea of noise at their home or office. What I'm showing here now was a Society of Broadcast Engineers newsletter article where Chris Imlay was describing a presentation I did for the NAB, and he was described. So we were trying to spread the word. That's the only reason I show this. And in this case, I'm sharing the info with my fellow broadcast engineers. In 2016, there was a technical advisory council, officially formed by the FCC to study this problem. And people commented on it. I did, and a significant number of people who were players in the industry and hams and others did get involved. And there was calls for a noise study to be performed. There have been studies of that sort done in Europe, which are very, very interesting and helpful, but I don't think anything's ever been done that I know about in North America. Generally speaking, the perception with all the commenters was there is a problem, and we're calling on the FCC to help with doing this in cooperation with the people who are volunteering to be on this council. The expectation was that some sort of notice of inquiry, notice of proposed rulemaking, something would be done. And can I just sum it up by saying nothing was done? Here's a presentation done by a group of leading consulting engineers in the broadcast engineering racket. And they presented this personally to the FCC chairman. So I was going right to the head of the line. In 1993, a book was written by the FCC about interference for the public, and it has a lot of good advice in it. But when I checked again in 2024, it was still there, but they did add the word outdated to it. So we're not getting much help from this front. The FCC is uninterested in this, and they have a strong role to play. I should maybe be clearer on this point, because they regulate and have authority over any unintentional emitters of radio signal. So they need to step up and control that. There is a process in place for it, and there is testing that's meant to be done for consumer devices, but I feel that whole process has fallen completely apart. So on AM and shortwave radios, you can hear the buzzes, pops, and clicks. You may remember on analog television, which was the video part is an AM waveform, you could see the snow of random noise or wavy lines in the picture from a discrete carrier causing interference. And in other words, you could see in the picture and get clues to the nature of the interference. With FM receivers, that's much harder. It's much more subtle and vague, except that it's covering up any weak signal. And those signals that were sort of marginal for a listener get covered up, or their signal to noise ratio deteriorates. The digital systems, and that would include digital television, the modern HD TV, and the cellular telephones, Wi-Fi, all that stuff, generally has what I call a cliff effect. That is, reception or data transfer is perfect up to the point where it isn't. And there's a very sharp point in the signal to noise ratio change that above that threshold, you're going to get pixelation of a video or packet dropout for a data transmission. Below that, threshold, you're running all right. Or maybe I could say that in the opposite way, but you follow me. The device is working, and then when the interference gets to be too much, it can't cope with it anymore, and you fall off the cliff. So just to reiterate this point, on the left side of this photo, you can see some discrete signal interference to analog television, and on the right, you see some examples of interference to digital. So I can look at that TV and know, like I said, that that's a discrete signal mixing. It's a heterodyne, basically. Or if I saw snow, or if I saw bars or popping, periodic signals, that's all good clues. Digital TV and other digital modes, you're not getting those clues. So people they don't even know it's a noise problem. They think, oh, I don't have a good enough antenna, if they even think that much about it. And it's even worse, the situation with Wi-Fi and other sort of wireless devices. That term has gone back into vogue, and antique wireless is now on the cutting edge, apparently, with use of that terminology. But wireless products, people don't really even quite know that it's radio, and that's a shame. So just to sort of review what I see as the problem, growing levels of radio noise are hurting otherwise good signals and then making those systems less useful. I think we need to spread awareness of the problem. I can testify with confidence that non-radio devices are being made and sold without adequate concern for incidental noise radiation. And this really has an effect indoors. And I'll prove some of that here in a moment. Outdoor systems that are not meant to radiate, power lines, cable TV, traffic control equipment, that's one I discovered in the last 10 years, are not being properly designed and maintained to keep them from causing interference. And regulatory agencies seem to have lost control of the situation. So I did some measurements, and I didn't get any, I don't have numbers to show you, but what I'm doing is an A to A, apples to apples comparison of the reception of FM signals indoors versus outdoors to show you that the problem is, one piece of the puzzle is consumer electronic gear that's in houses by the truckload now that are just spraying too much RF around unintentionally. And of course, these results, since FM is around 100 megahertz, it would apply to VHF, and I can say UHF as well. And usually, I don't think it's fair to say every time, but usually those same houses will be very noisy for lower frequencies as well, HF and below. So I studied 3 locations: suburban houses, urban apartments, and urban office settings. I used a portable spectrum analyzer, which was set so the span was for the whole FM broadcast band. And I had a small loop. I think it was a quarter wavelength in circumference, nothing magic about that. It was just meant to sample the electromagnetic situation in the locations. So I visited take this example. I did multiple ones, but here's a good example, and I documented thoroughly. Suburban house. Here's how the FM band looked out in the driveway outside that house. You got lots of big signals standing up tall and proud, and you have some noise in the background, but some of the stations are suffering, but most are not. Here's what it was when I stepped inside and went to the threshold and stood sort of in the vestibule of that house. So noise is now covering up many of the signals. Only a few are standing out above that noise level. So moving to compare them side by side makes it maybe a little easier to see outdoors versus indoors. So there may be some signal shielding going on. I did not change the reference of the signal. These are an apples to apples comparison. All I did was walk inside and take another screenshot of the analyzer. So I found some apartments, and this one is an attractively architecturally interesting building with a very interesting name. History buffs might recognize that name as having some significance in history. Others won't. Doesn't matter. It's not the same guy, I'm sure. It was actually, I can say it was a doctor's office originally, and now it's apartments. Here's what it was like on the sidewalk out in front of the building. Plenty of big signals standing up. Different strengths on the signals because I'm in a different part of the city. Background noise, manageable, not too crazy. There it is in the hallway inside the apartment building. Noise level much higher. Some signals still standing out, doing pretty good. I think this downtown location probably was better served by FMs. So they were, would naturally design their stations to cover the urban center. So you got some benefits of stronger FMs, but the noise level is out of control. Again, comparing outdoors to indoors. And finally, I tried some office buildings. This one was on the University of Wisconsin campus. Here's what it was like on the sidewalk out in front of the building. 98.1, I think it is very strong there, right in the middle. But the generally speaking, the background noise is okay. But and the signals are standing up, easily receivable signal to noise ratio. But I walk inside the building and we're getting blockage of the desired signals and a very high noise level. So the comparison of outdoors to indoors, pretty harsh under this office building scenario. So to summarize these results, again, I'm not making absolute measurements. What I'm doing is comparing the apples to apples situation of indoors to outdoors. I contacted several engineers involved in the manufacture of consumer electronic devices, and they all confirmed that these devices were being made without adequate concern for their incidental RF radiation. Anecdotally, I can say that the prototypes, based on what these fellows told me, the prototypes are RFI tested in most cases, at least these guys, but the actual products are being built in faraway lands to cheaper standards and not to the same specs that were tested. Also, products are equipped with power supplies that were not original to when tested. So then the switching power supplies can be a major source of radio noise. So in other words, the product being sold doesn't have the same power supply that was tested for RF interference when they tested the overall product originally. So I've fought a lot of noise problems. I keep my own homes as free of noise as possible. So I can speak to, what are some typical noise sources? Indoors, we see switching power supplies, as I mentioned, generally consumer electronics, TV sets, computer monitors, PCs themselves. Also lighting systems, specialized or just ordinary lighting can be a source. A lot of times the modern lights are being powered through switching techniques, and they have power lines attached to them that are good antennas to radiate it. Outdoors, we still get lots of noise from power lines. Probably, maybe in some places worse than ever because of lack of maintenance. Cable TV systems leak. The telephone data services that try to run a carrier of wideband data on top of a pair of phone wires tend to spray RF all over the place. And as I mentioned way early in the talk, traffic lights and other roadway systems can be a culprit. So I'll just show some devices that I've run into over the years that were very noisy. Here's an RCA Thompson DVD and CD player that a listener had, and it was harsh. It was really spinning out a lot of noise when it was turned off. It has, but so many devices today are not really turned off. They're just in a sense, put to sleep by the power button. And the power supply is still active and some portion of the circuits are active. So I had the fellow, in this case, plug his unit into an outlet strip so he could just completely cut the power to it and stop the interference. Here was a battery charger for an electric scooter, sort of a hybrid of a scooter and a bicycle. I looked at the specs on it. It fortunately did have a label that showed, what voltage at what current, and I replaced it with a linear power supply. So that solved that. That one, another one, that was tearing up a neighborhood's reception. This was a power supply for a monitor. Sometimes they're built into the monitor, other times they're an external unit like this. Either way, they can make noise. This was a cell phone charger for a flip phone back in the day. Again, another very, very likely source of noise. I do find the Apple chargers have the ones I've encountered have been dead quiet radio-wise. So I give them credit for that. I don't like everything that company does, but that is a really good thing. But any of the clones I've tried of their products were usually pretty noisy. Oh, notice that it's from Motorola too. Motorola being a radio communications company at its heart. This was a home network router power supply. So it powered a device that did wireless networking for a house, as well as had 5 or 6 Ethernet cables attached to it. And those cables were conducting the noise from the router all over the house. And the user, he was fixated, and he was a ham. This fellow, he was fixated on the idea that it was the wireless part of it making interference. And I said, no, I'm betting it's the power supply, and that the Ethernet cables are just spreading it around, common mode energy on them that's radiating. And indeed, when we switched it to a linear power supply, which I had with me, that I had bought at a thrift store, those signals were gone. That interference was gone, and he was very pleased. He couldn't operate HF when this system was running otherwise. But it was the power supply that was the issue. But it was facilitated in its interference potential by all the wiring distributed around the house to carry the Ethernet signals from the router. This was a notebook PC, a laptop power supply that was very noisy, and I replaced it with a linear supply. This was actually an analog TV set that was very interference prone. I love the name of it, Broke Sonic. Couldn't be better. A very noisy thing. Interesting story about the microwave oven. They can make general interference. They can make interference when they're just sitting and not running. They can make interference when they're actually microwaving, because that's actually a transmitter, and could have outputs on the desired frequency or elsewhere. But in this case, I had a reception problem reported from a listener who was in vision sight of our flagship FM station in Madison, Wisconsin. And she said that she'd been listening in her kitchen on the same radio for probably 20 years. And now she couldn't hear the station at all. She said it was dead quiet. So I talked her through it, and I said, do you have any new electronics in your kitchen area? She said, yeah, we just bought a new microwave the other day. I said, well, can you unplug it? I skipped all the turning it off stuff. I said, can you actually unplug it? And luckily, it was not a built-in unit. It was a tabletop unit like I'm showing in this photo. And she was willing to play along, and she did unplug it. And in the background on the phone while I'm talking to her, I hear the signal come in beautifully. And she said, oh my gosh, it sounds great now. And I said, well, I bet if you plug the microwave back in, it will disappear again. And sure enough, there was a discrete carrier blocking out the reception of what was a very strong FM signal in that location. It might have been being conducted along the AC cords and stuff in that room. That's possible too, but I didn't go any further than that. I said, I think you need to get a different microwave. And she took it back to the store but she ended up with the same make and model again. And then she called me and she said, well, it's doing it again. And I got a new one, like you said. And I said, no, I'm sorry, you misunderstood. I meant to get a different make and model. And she did that. She really wanted to listen to our station. And that did the trick. So whatever, maybe I think probably the control panel on that microwave, because it wasn't that she was cooking anything in it. I think it was just putting out a signal right on top of our station. Inadvertently, it's not intended to do that. Now, this is it's been discussed quite a bit in the literature, shall we say, and QST and other places, but indoor gardening enthusiasts, people who like to grow things in their basement or whatever, will use these lighting ballasts to run special grow lights. And they have been known to be very, very noisy. But also people don't want to admit sometimes that they're using them. If you're trying to work with your neighbors or whatever, they won't really play along because they're trying to keep that gardening secret. But anyhow, that's a different topic, I suppose, but it's a switching power supply. It all boils down to that most of the time. And power companies, of course, still have problems, and they usually, though, you can only get them to fix things that are really dramatic, that you can say, it's going to burn the pole down pretty soon. Although there are notable exceptions. The power co-op in Madison, Wisconsin was very good about solving power. Like they understood that if there was radio noise coming off the power lines, there was actually a power leak. Something was, current was flowing over an insulator. You had a broken connection that was arcing, something like that. And they wanted to do the maintenance on those things. So I give them a lot of credit, but I've had other companies that didn't even understand what I was talking about. Idaho Power would be a good example of that. So the problem I see it, just to sort of summarize again, is this is a growing problem. It's hurting otherwise receivable signals. It's spoiling ham and shortwave listener experiences. It's contributing to the decline of broadcasting. It's not the whole story by any means, but it is a part of it. We're going to have a lot of electric vehicles driving around that are so notoriously noisy that they don't even put AM radios in them. But they think that solves the problem? No, they're still driving around town radiating all that noise. So that's nothing to be sneezed at. Definitely, I've confirmed from engineers involved directly that non-radio devices are being made and sold without adequate concern for the incidental radiation of radio signals. And that definitely is going to cause interference levels to increase. One study I saw done in Europe, they could actually see the noise level in a given city or just let's say a rural location, that might be fairer. They could see the noise level go up and down due to ionospheric propagation of the noise from a distant city. So there was so much RF random nonsense out of a city, say in the eastern part of Europe, that you could see it as the gray line moved over Europe. You could see the various cities come into view. Really amazing how bad that was getting. Also, I didn't put it in this presentation. I have another presentation on tracking radio interference and finding it. And that slide is in that one, I believe. And but anyways, it was about GPS signal loss in aircraft. It's a growing problem, and it's admittedly in a few places there's a problem with spoofing or jamming of GPS. But in this case, most of the problems were just a high background noise level in a location, and the aircraft would lose GPS lock. And that's a big deal because aviation now relies heavily on GPS. So the outdoor systems that are not meant to radiate shouldn't be radiating. And we need to deal with those problems as they come up and try to give feedback to the companies involved that they need to attend to these issues. And again, I don't know an answer to a lot of these problems, but I do feel the regulatory agencies are not enforcing the rules they already have. Companies particularly in foreign locations, manufacturing products with FCC acceptance and logos and everything that they never touched a testing facility. So there's a problem.